Okay, so then we can start. Yes, so
Okay, the recording started.
do you have any, question in the chat, or anybody share the questions that they find difficult, or what, like how does it work?
Well, if you have any kind of questions, doctor, that you're giving to students that you can solve, sharing your screen and
Mm.
solve it, that would be great. Or if anyone has a question, he can post it in the chat and then the doctor will solve it.
Okay. So mm, this is the case, then I think I think we can start with the quiz questions, quizzes. I think all quizzes, and mm, mm, or if you have those, I mean, um, okay. Games and
Okay, someone have sent a question in the chat, doctor?
yes, I sorry.
Yeah.
Okay, so like all of you can see the screen, like not the screen, like all of you can see the question. The question
Yeah,
is
we
using the
can.
perceptual learning with
Oh,
weights W. So we have three weights, and one is W0. We can use it as bias, and the data is three-dimensional. X1, X2, X3. The values are 3, 2, and 2. The function that we are going to use is h parameterized by w and x. So this question, yeah, let me share my screen. Mm, mm, yes, I think it's unshared. Okay, let me share again. Yes. Okay. Can you see my screen?
yeah, we can. Yeah.
Okay. So this question is very simple. I mean, there is actually a lot of clue in the answers as well. So first, you need to understand the question. The question is about perceptron learning, and in perceptron learning, unlike K and N, where you actually find the relationship with the help of neighborhood relationship, here you have a decision boundary defined by the weights. So these weights actually are creating one hyperplane or a plane in this space, like in this data space, which actually separates points. And we have one non-linearity, which is this function, h function, which is parameterized by w. And although it's not given here, but we remember from the perceptual learning that this h is a stepwise function. So what is a stepwise function? The it is a function which produce either 0 or 1 or some discrete values, is on the some threshold. So by default, this threshold is understood to be zero because we have bias, and with the bias we can control it. So all you need to do is simply multiply the W1, W2, W3 with these values, X1, X2, X3, and add bias in it. So here you can see that we are actually multiplying 2 with 3 is 2. Okay, can you see my pointer? I don't think so. You can see. Let me bring my mouse or something to show you that without pointer. Yeah, just a minute. Just a minute. Okay. Oh, we actually this is like a new thing for me. That's why it's taking too long. Yeah. Yeah. uh, yeah. Can you see the screen? Hmm?
Uh, yes, we can, but have you written something on the screen or?
No, it's just a white screen and it's
Yeah, we can, yeah.
okay. White screen.
Now we couldn't.
Yeah, yeah. Is it okay? Can you see it?
Yeah, now we can, yeah.
Okay. So here you have weights. Okay, and this is your bias, and these three are the weights of these three variables. So if you remember the formula of perceptron learning, it says the h function parameterized by w. Okay, and it takes the value x, and if the sum weighted sum of x and w for all values is greater than equals to 0, the function will output 1. Otherwise, otherwise it just give you 0, which means this we have to calculate this sum of the weighted sum of x and w. And obviously we have 4 values in weight and 3 values in x. This could confuse. So bias, this term, which is bias, okay, this bias term, use a blue color, and this bias term is always multiply with 1. Okay, all you need to do is simply multiply w1 with x1, then add w2 multiply by x2 plus w3 multiply by x3. So you can solve it on your side and then add the bias. So here bias is w0. Well, you can place w0 in the beginning or in the last, doesn't make any difference. And if this value is greater than or equals to 0, it means the output of our h will be 1. Okay, and otherwise it's going to be 0. So first thing that you can easily see from this question is that you have two possible outcomes, one or zero. So uh, either it is this one is true or this one is true. This one is false. This one is false. I mean, wrong one. And because none of the above given answer is correct, this yeah. So or this could be an option, but we know it's either zero or one. So we only have two options, zero and one. Now perform the calculation and see what's the outcome. So W1 is is 2, 2 multiplied by 3, 6, 0 multiplied by 2 is 0, minus 1 multiplied by 2 is minus 2. So minus 2 and 6. It is minus 2 and 6, and then subtracting the minus 4. So the value is 0, and then you feed this value to this function. This function says greater than equals to 0. So because 0 is in its range, then it produced output 1. So this is why 1 is a correct answer. I hope actually this explain you like how it works. There are two concepts. One, you are actually taking the summation, like how perceptron work, and then how activation function works. Although the sum is 0, but the threshold is at the 0 as well. So because it's in the range, so we produce output 1. Any other question?
Doctor,
Yes.
the threshold always 0 or 1.
Yes. This is
So
this is the this is the threshold, and z at 0 or greater than equals to 0. On this side it is 1, on other side, this one side, it is 0. So your weighted sum is at this point. So at 0 and greater than equals to 0, the output is 1.
even if the question does not mention that.
Yeah, this is actually it's actually highlighting the right answer, but mentioning the wrong one. Actually, this is a typo, I guess.
Also, this confused me, so I bring
Yeah,
that. Okay, thank you,
yeah.
Doctor.
Yeah, thank you for bringing it. Yeah, this should be C. It's not A. You see, it's multiplying with the and the sum is actually greater than equals to 0. So the output of the threshold is 1. So the question is the function threshold is evaluated to be 1, and everything is correct. The only error is here. It's a typo, clearly. Okay. Uh, any other question? Yeah.
Yeah, there's a second question from Abdul Majid. Yeah,
Okay.
yeah, that one.
Suppose we have fully connected neural network with the following given architecture: number of inputs in the input layer is 2, and the number of hidden layers are 3. The number of perceptron in each hidden layer is 4. Number of perceptron in the output layer is 1. What will be the total number of weight biases that we will need to train? Okay, so first we have input layer. And input layer we have two inputs. Okay, so this is our scenario. Let's bring the question here so we can. Okay, now yes. So we have three layers. Hidden layer is 3. So first input layer, second hidden, third is hidden, fourth is hidden, and the output. So these three are our hidden layers. Okay, and input. How many inputs we have? Input layer. The number of inputs are 2. So we have two inputs. Okay. Next, the number of hidden layer 3 and the number of perceptron in each layer is 4. So we have 4 neurons here. 3, 4, 1, 2, 3, 4. 1, 2, 3, 4. So 4 neurons here, 4 neurons here, and 4 neurons here. Number of perceptrons in the output layer is okay. So 1, 2, 4, 4, 4, 1. This is the architecture. Yeah, it was on hold for some. Why? I saw the screen was on hold.
Yeah, Doctor, we cannot hear you.
Yeah, I don't know why screen just went off. But anyway, so yeah. Okay, so this is the configuration we have. Okay, we have 3 layers, and in each layer we have 4 neurons. And input we have 2 neurons, and output input we have 2 inputs, and the output we have just single neuron. Because it's fully connected, so all perceptrons are connected with each other in the neighboring layers. So here we have 4 by 4 weights. Here again we have 4 by 4 weights, and here we have 4 by 1 weights, and here we have 2 by 4. Okay, so this is the weight. So 8, 16, 16, and 4. So this is the weights. Now, in each layer, there will be some bias as well. So here we have one bias, here we'll have one bias, here again we will have one bias and one bias. So in total, we have okay, how many biases we have? Okay, this is 1, 2, and 3. That's total is no, 1, 2, 3. The output layer is okay. I think there is one additional. I think okay, let's count it. So 8 and 16 and 16, 40, 40 and plus 40 plus uh, so yes, so 40 plus it's total 44. So total 44 weights we have, and then we will have additional biases. So for each neuron here, you see this one is add to here, and then you will add one bias, and then these two will add and give you another bias. So total 4, 4, 4, and one bias. So total 13 biases and 44 weights. The sum will be 57. So let's is it, if it's not clear, let me explain. The 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 biases are for each neuron. Okay, for each neuron. So here you have 4 neurons. Each neuron have one bias, 4 bias, 4 bias, 4 bias. Total here 12 bias in the hidden layer, and the one bias for the last layer. So total 13 biases, and the weights are between the connections. So this is why we have 44 connections. Yeah, somebody actually raised a hand. I think.
So, Doctor, the bias is only for the hidden layers and for the output. For each
Yes,
neuron is
yes,
bias. The input does not have any bias.
yes, because input in the input there is no neuron. Input is just a kind of a just telling input layer is just imaginary layer. It does not contain anything. It's just telling you how many inputs are there. Okay.
Okay, thank you, Doctor.
Okay. You remember the perceptron. It's the same as single perceptron learning algorithm. We actually calculate this weighted sum. Remember the W0 from wi to wx. From it is. If you remember the previous question, it's actually related to this one. Here you can see that you have one perceptron and it's taking 3 input and it's a 1 bias. So these 3 are its weight and 1 is additional bias. Same as here. It's this is actually for slightly larger scale. So here in each neuron is actually require 1 bias. So total you have 4 neurons here, 4 neurons here, and 4 neurons here. So yeah, biases like total bias is equal to the total number of neurons you have. Simple. And the connections define the number of weights. Okay, let's move to if there is no question related to this one, then we can move to the other. Okay. Okay, this one. Can you see my screen?
Yeah, we can.
Or
Yes.
like, or do
Yes,
you
we
want me
can.
to continue with the like if you have any question here, we can. Otherwise, we can move to the next question. Okay, let's move to this one. So this is related to SEM. SEM maximize the margin around the separating hyperplane. Suppose that you train SEM on the data set with 6 points as shown in the following figure. The data set contains 3 samples with the class label -1 and 3 samples with class label +1. So we need to zoom in to see. So here you have actually it's not quite visible, but I think there are 2 classes. One is triangle and the second one is a square. Okay, these 3 points are the triangles and the top points are the square. Any confusion here? All of you can see it easily. Is it? Okay.
Yes, it's clear that way.
Okay. Now the question is which of the following option is correct? Um, corresponding to the maximum margin equation corresponding to the maximum margin decision boundary. Okay. So what does it mean? It means the weights. If you know the weights, then you can find the uh, the um, if you know the weights, then you can find the decision boundary. So here uh, we have we actually it requires some solutions calculations. So we'll come back to this one. I think that let's just solve the easy one first. So in the above figure, what would be the width of the maximum margin? So before that, you need to identify which points actually make the decision support vector. So can you identify? I will ask. Uh, okay. Is this point a support vector? No.
No.
No. No.
Similarly, is this a support vector? No. Okay. And is this a support vector?
Yes.
Yes.
Yeah. So this is actually a little tricky here. Uh, it is it is not a support vector, and this is actually quite confusing in many cases. Students put this one and this one as support vector. Okay, but this is not. These two are not support vectors. They happen to lie on support vector like a hyperplane because support the definition. What's the definition of support vector? Support vectors are the points. Support vectors are those.
Doctor, we can't hear you.
Doctor, you're muted.
Sorry, yeah. Can you hear me now?
Yes, we
Yeah.
can.
Yeah. So So we discussed that this is not a support vector. This is also not a support vector. And in fact, this one and this one is also not a support vector. And this was the main confusion, and in many I saw in many SVM problems which I shared earlier.
Doctor,
So yes,
how you can know if is it support vector or not, just by looking or
yeah. So uh, so let me first give you the definition of support vector. Support vectors are the points uh, which you remove. If you remove them, they will actually increase the the margin between the hyperplanes, or the margin between the two classes data. So a simple answer is the minimum distance between two samples of the other class defines the support vector. So let's redo this task and see. So if we calculate distance from this point, so the distance from this one and this one and this one and this one and this one is this one. Okay, this is you can either determine these three distances. Obviously, you don't need to do this because here you can clearly visually see that which point actually in the is the closest to the other class. So let me ignore this one and this one. Okay, you all of you actually know that these two are not the support vector. The confusion is in this one and this one. Okay, so if I use this one, what is the distance between uh, this sample and the sample of the other class? Okay, so we have this distance. Okay, and this distance. So obviously this is quite big distance. Let's call it D1, and this is relatively small distance D2. You can visually see. Hmm? Now the third distance is the is this distance and this distance. Again, D3 is larger than D4. Any confusion here? So we have 4 points, and in between these points, you have 4 distances. Okay. Now, which distance is the minimum one? By just visually looking at the distance, can you tell
D4.
like which? Hmm?
D4.
D4.
D4. So it tells you that these 2 points are most closest to each other, and any error in the classification, if it occur, it will because of these 2 points, because they will bring our hyperplane close. And now let's use the same concept and find out. If I remove this point, if I remove this point,
Doctor, I cannot hear you.
yes, I don't know why it's actually disconnecting. Can you hear me again? Yeah, I
Yeah, we
don't
Yes,
can.
know.
yes. Yes, now we
Yeah,
can.
sorry, I mean just so it's uh so we were discussing this one. So even if I remove this point, the top point, it will not uh reduce my margin. Okay, like if I remove it, the minimum the maximum margin is this one. Okay, if I remove it or not, the maximum margin remain the same. So support vectors are those points which if you remove them, they will increase the margin. But if I remove this point, you see now my decision boundary is can be can be increased by this factor. This will be my decision boundary. So the total size, the size of the decision boundary will increase, but this is the current decision boundary is defined by this one. Okay, let's clean it again, and then I will ask you. The reason why student is actually confused this one as a support vector, because first we have the support vector and then we draw hyperplane. These 2 points, this point and this point, happens to lie on the hyperplane. These points actually do not create the hyperplane is actually passing from these 2 points, and it's just coincidence. Okay, this is why this answer is also incorrect. I think there should be like, yeah, it requires some correction, and we only these 2 points are our support vector. Okay, what these points are, let's see. Let's zoom in. Okay, so one is 4, 6 and 6, 4. 4, 6 and 6, 4 are our decision support vectors. Not all 4. Only 2 support vectors here. Okay. The answer is 4, 6 and 6, 4. Okay, so there is a mistake here. This is incorrect. This is incorrect. Only these 2 are our support vectors. Okay.
Doctor,
Yes.
if we remove both the lower one and the above one,
Yes.
will the margin will change?
No. You can see, because margin is defined by these 2 points. You can see that these 2 points are most closest opposite class samples. Other points, they are very far. I mean, the margin only increase when you remove any of these points. Okay, so let's just calculate the margin. Okay, how about this? Let's calculate the distance. Okay, calculate the distance between this one, and this one, and this one. So obviously we can clearly see that this one is very large, the last one. Okay, this one is very large, so we don't need to calculate it. Let's just for the sake of understanding, find the distance between these 2 points. So we have 4, 6 and 6, 4. Calculate the distance between. Remember the formula for calculating the distance between 2 points. It is x2 minus x1 whole square. Depending on how you define this is yeah. So it is defined. It's a just Euclidean distance formula. So 6 minus 4 is 2, and 6 minus 4 is 2. So 2 square, 4 plus 4, 4 plus 4 is 8, and square root of 8 is 2 root 2. This is the margin. Can you and what's the value of this one? This is square root of 2 is 1.41.
C.
1.41 multiplied
2.82.
2. Yeah, so 2 point, because the square root of 2 is 1.41. So this is our margin, maximum margin. Okay, because maximum margin is defined by these 2 points. The other points, this is incorrect, this is incorrect. Okay. And just for the sake of your understanding, you can calculate distance, like distance between these 2 points. Let's see. If we calculate distance between these 2 points, this is 6, 6, 4. So 4, 6, same point, and this is 2, 4. So 4, 4, 0. This is 2 and 6. So 2 minus 6 is 4, and square of 4 is 4. So this will give us 4 margin. This is 2.8 something. So this you can clearly see that this one is giving you a very large margin compared to this one. The smallest margin defines the support vector. Okay. I think whoever bring this question, thank him, because now you see this is actually very confusing, student, because in the past paper the solution is incorrect. Okay.
So, Doctor, Doctor, do you suggest that we study from the old exams rather than these slides? Because many questions were answered wrong.
Yeah, I mean that this is the purpose of this session and the session in the class. If you try it in the like this is why we have this additional week. If you practice it and bring it into the class, your faculty, your professor can help you, you know, understand the concept. And if there is any typo or any mistake in the past paper, we can really clarify these things to you. So I mean, we can use this opportunity, and I think I hope you understand the concept of margin. So margin is defined by the minimum distance between 2 points, and those 2 points will define the support vector. So these 2 points have the minimum distance. This is why these are our support vectors, and the margin is 2 point. So I hope that these 2 these 2 questions are clear to everyone.
Someone has a question, Doctor.
Okay.
Mu'taz?
What
Yes,
about
Doctor.
it?
It was about the question. My question.
Yeah. Even the top one here.
Yeah.
Yeah. So
Yeah,
first
it's
we
the
need
most
to
confusing
that.
one.
So first you need to understand that there's 19 and 20. You get it?
Yes, I get it.
Yes.
Okay. So 19 and 20 are very easy if you understand how to identify the support vector. So this is why I actually first started from the support vector. Okay. So we know that this is a support vector by just simply looking at it, because this is the shortest distance. Okay. Shortest distance. So can you find the slope of this line? Can you find the slope of this line? And if you don't know how to find the slope, it's the formula is very simple. It is uh, just subtract the uh, zoom in. Anybody who don't know how to find the slope, or you can mention. Otherwise, it's very simple. So this is y. So 6 minus 4. See the x2 component. I'm subtracting this one, and this one. Delta x2 divided by delta x1. So delta x2 divided by, oh, let's just clean it. So slope, the formula of slope is delta x2 divided by delta x1. So by delta, I mean the change. So here we have 6 and 4. So delta x is 2. And here we have 6 and 4. Then delta x is 2. So the slope is 1. Okay. Slope is 1. Any confusion in understanding the slope? So the slope of this line is -1. Sorry, -1, because the change is negative. Here 4 minus 6 is -1, and 6 minus 4 is 2. Yeah, it's 1. So this is -2. Yeah.
Doctor, it will be 6 minus 4 over 4 minus 6.
Yeah. So this is why it is minus.
Yes.
Okay. So we have -1 slope. Now we know the support vector give the hyperplanes are this margin is the orthogonal distance between two hyperplanes. Okay, so the hyperplanes are orthogonal to this line. Okay, so orthogonal means is this one and this one. So okay, so if we can find a slope of this line, we can simply find the slope of the orthogonal line. So the slope of the orthogonal line is m2 which is equals to -1 over m1. So just put this slope here, you will get, so m2 is +1. So this is the positive slope, and just for your proof, you can check when slope is equals to 1, it means that for every change in x1, it is changing with the same unit. So if it's going from 4 to 5, this will go from the next, here we have 4 and 2. So for 6, it is 4. You see the change here in x, you have a change of 2. In y, you also have a change of 2. This is just clearly quite self-explanatory. Now, if you remember the equation of the line, equation of line is defined by this one, mx plus b. Here is y is our x2, m is m, and x is x1, and b is simply the y-intercept. Okay. Or we can solve it in many ways, but I'm just showing you one way. But if you need very straightforward solution, so let's clean it. One way is I can simply solve it. The other way is I give you the idea about the different concepts. So anybody who have confusion in calculating the slope of this line, like if you have any question, just ask me. Okay. Cannot see any question, so let's move forward. Anybody who have confusion in finding the slope, orthogonal slope? Orthogonal slope is just simply -1 divided by the slope of the other line. Okay. Now we have slope and we have points. To find the equation of the line, what you need is you need to find the equation, you need point and its slope. If you know the slope and the point, you can determine the equation of the line. Okay. If you know the slope of the line, you can determine its equation. So here we know that the this hyperplane have this point and its slope is 1. And if you use this formula, which is x2 ax2 ax1 plus b x2 plus c is equals to 0. This is the equation of the line. Okay. Or if you use this formula, these are two formulas for the to determine the lines, equation of the line. This one use 2 points, and this one is using a point and a slope. See, point and a slope. So whatever you choose, you can determine the value of the b. So let's say I'm finding the equation of this hyperplane h1. Okay, so this hyperplane is passing through this point, and the point is 4, 6. So x1 is 4 and x2 is 6. Let's put this here. So x2 is 6, x2 is 6 is equals to m is simply 1, 6, x1 is 4, and b is, we don't know. Okay, so we can find the value of b equals to 2. Okay, Now you have this hyperplane, equation of this hyperplane. You can do the same and determine the equation of the other hyperplane. So the first hyperplane is x2 x1 plus b and x1 minus x2 plus b is equals to 0. This is the equation of this hyperplane. Now for this one, you can do the same, and it will be very nice if you can tell me the equation of this hyperplane. So use the same formula, which is x2 m multiplied by x1 plus b. So for this one, we have to identify the value of b, and slope is again 1, x2 is 4, and x1 is 6. So total is 4, 6 plus b. Here b is -2. So we have two hyperplanes, and the actual class separation boundary pass through the from the mid of these two hyperplanes. Okay, and if it passed through this in the mid of this one, so the slope will remain same, m will remain same. The only value will change is the b. So half of the b. Yeah, either you can change, make a half of this one or that one. You will get the equation. So this is you see this is the candidate's equation. We have all of them have half weights. And I know it's actually I brought so many concepts here, but I believe that it was important rather than just simply answering the questions directly. Oh, okay, so the line will pass from this point, this imaginary point, and the equation of this one is 5 and 5, and the slope will be 1. So let's calculate x2 x2 uh, x2 plus x2 is equals to m x1 plus b, and x2 is 5, m is 1 and 5, and b is, so b will be 0. B is 0, and that's this actually determines, this is why we have 0 here. So this is wrong, and this is wrong. You have to choose between these two lines. Okay, and now what is left is how to choose between these two. So which of the following options is the corresponding equation corresponding to the maximum margin decision boundary? Here, the reason actually you have this half value is, I mean, this question is, some people actually solve it with a trick, but I don't. I actually go through all the process just to show that what else is involved. So I first actually give you the idea about what support vectors are, and then what is decision boundary, how to calculate it, and then why these two are wrong. And now we are left with this one. Okay. So which of the following option is correct equation corresponding to the maximum margin decision boundary? So equation which is representing this this line. Okay, so let's calculate this line, and the idea is this is this one, a x1 plus B, idea is this: M is equals to x2 minus x2 prime divided by x1 minus x1 prime. When I say x1 prime and x2 prime is, I'm using, for instance, this one as my x1 prime, x2 prime, and the other one is just x1 and x2. Okay, so we know the slope is -1. This slope is -1, and x2 is 6 minus 6 prime is 4, and this one is just okay. Sorry, just leave it as it is. X. Yeah, I don't. I should actually bring the pointer, but x2, and this one is x1 minus this one, which is 6, and the total answer become x1 minus 6 multiplied by -1 is equals to just cross multiplication, and x2 minus 4. And when you solve it, it becomes 6 minus x1, x2 is 4, and x1 minus x2, I'm sorry, x, yeah. So here we are taking x2 minus x1. You have 2 here because 6 will go there, and if it's greater than equals to 1, if it's greater than 2, or okay, let me finish it first, and then I will apply the condition. Now dividing it with the and we are using this as a threshold, so you can make like this way, minus. So this line is our decision boundary line, and the weights actually, these are my weights, and if the weighted sum is above the some threshold, then I will I will assign the class label 1. And if the weight is below the certain threshold, I will assign the class label as 0. So yeah, you can find some easy direct method to calculate it, but this is actually all detailed method which cover all the topics like what's decision boundary. And so if you need more, you can leave it here, and we will revisit it. And if you have more questions related to this question, we will come back. Okay, so all I try to explain each and every point, like why we have minus here, and like why we are not using this one, why we are not using this one, and why we are actually using this one or this one. And because if you see from the weight equation, you have negative weights, so weight 1 and weight 2, weighted sum, and this is our the right answer, and for some reason which I explained. Okay, I think I've put a lot of time in this question. We have other question here is this one. Given the data set below, where 5 samples are labeled as squares, and the diamond, which of the following figures show the correct decision boundary for one nearest neighborhood? This is also very this kind of question could be problematic. So let's say which question you're talking, is it 36 or 37?
36, Doctor, I guess.
36. So 36 is yeah, it's not fully clear to me, but why this one is wrong? Because we are using one nearest neighborhood. So any line in which the distance between the decision boundary and the line is in a fraction, okay, is in half or like less than half, is wrong. So obviously this is wrong, this is wrong, and this one is also wrong. Yeah, it's not fully visible to me. I think, do you have any better version, like clear version, where you can just crop this part only? Because I cannot see the class levels.
Doctor, I sent the clear image in the chat for the graph.
Yeah, okay, yes. Okay. So we have this question. This is the question, and this is the figure. Okay, given the data set where 5 samples are labeled as a square and diamond, 5 samples, diamonds and squares, okay. And which of the given figures shows the correct decision boundary for one nearest neighborhood classifier trained on this data set? Okay, so here what you do is you find the midpoint between two neighboring points. For instance, here the midpoint is here, and it is orthogonal to. Let me put it here. So the midpoint of these two is
Doctor,
here.
you mean by the midpoint? Can I take the margin and divide it by 2?
But just simply visually see where the midpoint. Okay, and for this one, the midpoint should be here, and for these two, the midpoint should be here. Okay, so the midpoint tells you, okay, you draw from here to here, here to here, and this is from here to here, and this is like here to here. So it, let me show it again. It's with different colors. Okay, pointer. Let's start with the purple color. So here this is class A, this is class B. This circle, the square and diamond. Okay, in between this is the midpoint. Okay, and this midpoint is orthogonal. Now we using other points like this one, and this one. You have this midpoint, and it's orthogonal. Now this one and this one. It should be here and orthogonal. So orthogonal, and so you can see that the decision boundary is quite zigzag. It's like from here to here, from here to here, and from here to here, and then from here to here, and then here. So which one is actually correct? Because you see, this is the midpoint. So the decision boundary going this way. This is the midpoint. The decision boundary is going this way. This is the midpoint. The decision boundary is going this way. This is the midpoint. So decision boundary will pass through this one. So when you follow these traces, your decision boundary lines are perfectly matching with this one. Not this one, not this one, not this one, not this one. This is why figure B is actually representing the correct decision boundary. Okay. Just simply find the midpoint and draw the orthogonal line. Find the midpoint and draw the orthogonal line. Find the decision boundary and draw the orthogonal. Obviously, if you draw the orthogonal line, ideally it is going infinite, but just stop to the point where actually both lines intersect. Okay.
Doctor,
Yes.
do we have to draw a midpoint
No, it's
between every circle and diamond, or just 2 points?
no between the points of the class A and class B. So between all the all the nearest actually point, like from this one to this one, this one to this one, this one to this one, this one to this one. Why actually I didn't include it this one? Because it is very far from it. So if you pick this one, this is the closest one. Okay.
So only the closest one, huh?
Yeah, closest one actually. Okay. When you say decision boundary is something which is on the border side. Okay. So this is why we picked, we can visually see, because here you don't need to calculate, make any calculation, just visually see. This is actually not a right boundary. The boundary between these 2 points should be in the middle, from the middle of these 2 points, not from the, not biased towards this side, like this. Okay. This is from the middle of these 2 points. Okay. I hope it answers the question.
Okay.
Now, again, I think we have considered 2 separate classes shown in the figure, where the first class of the data points are shown in the circle in the class. Okay. Here again, it's a trickier question because it's related to SVM, and let me check if you remember the concept, what we learned. I know actually I make so many arguments in the previous question. It could be solved very easily, but I want to give you the full details so that you can solve the other question. Okay, here you have 2 classes data, and the question is asking if the points C3 and T3 are support vectors. So here the question is telling us that the C3 and T3 are my support vector. This is my C3 and this is the T3. If C3 and T3 are the support vectors, what can be said about C4 and T4? So first you have to understand what's this is your decision. This is your maximum margin. Okay, and maximum margin. Now the question is how to determine the slope. So if you use this line, orthogonal line, this is actually not a good classifier. Why? Because this point is misclassified. So the hyperplane should include all the points uh, in each class. Okay, so we know that this is our support vector. We know this is our support vector. So the decision boundary should pass like this. Why this? Why not the other? Why not like this? Because, or parallel, because we will miss this point and this point. Okay, and uh, so now we know that the T2, sorry, what is it? Yeah, T2 is here, and C4 are passing through our hyperplane. So what can be said about C2? The correct answer should be like this way. The C2 and T2, C4 and T2 are passing through the hyperplanes, but both point also identify the support vector. It's in a mathematical sense, we can say the both points can also satisfy the equation of the support vector, the hyperplanes equation. So this wording is is only true when this T2 and C4 are support vector. So in the previous question, I explained you the definition of support vector. What is the definition of support vector? Support vectors are the point. If you remove them, they will increase the margin. So is it possible to, increase the margin by removing them? Okay, if I remove it, the margin is this one. It's not changing. Okay, if I remove this one, the margin is not changing. But what about if I remove this one? Margin is still same because the T3 is a parallel actually to T2. This is why if you remove either T4 or or T3, yes, T3, yeah, either T3. It's very unclear. T3 or T2. If you remove this one or this one, the margin will not change. But if you remove both, only then margin will change. It means both T2 and T3 are actually on my hyperplane, which is making a support vector. So this is why both T2 and T3 belongs to the. Can you say the same thing about C4? Let's see. So if you remove C4, the margin is this one. This let me use different color, blue one. The margin is this. Okay, what if I remove the C3? So the margin is this. Again, this margin is same as this margin because C3 is and C4. If you remove any of it, let's say if I remove this one or this one, then margin will not change. The margin will only change if I remove both. So this is why answer A is correct. I, I hope it clarify the answer, or if you find it more confusing, that's just please ask question.
Doctor, I thought that if we remove both T2 and C4, the margin will increase. So one of them has to be a support vector. This is according to the definitions in the slides. Isn't this the correct answer?
No, if you remove one, for example, if you remove
if we remove T2 and C4 both, which is asking about.
Yeah, I mean, if you remove this one and this one.
No, not this one. T2 and C4, Doctor.
T2 and C4.
Yeah,
C4
if we remove
is here.
Yeah, he's asking about these. If we remove both of them, the margin will increase. This include this is conclude one of them must be a vector, a support vector, not both of them, right?
Okay, so support vector is in pair form. Okay, the first thing is it's in a pair form. One sample from the support vector should be from class A, the other from the one from the positive class and the other from the negative class. Okay, so if you remove this one and this one, the margin will remain same. This is the margin. Okay, let me show you the margin in red color. This is the margin. Okay, if you remove this one and this one, is it gonna the margin gonna change? No, the margin is same. And even here, if you see this margin, which is between C3 and T2, because the margin is same, like this is the margin, and you can see margin is 4 minus 2, and here you have 1 point something something. It's a 3 minus 1, so it's 3 minus 1. Either you use this one, margin 1, the distance 1, or use this one, D2. So in this question specifically, the distance, the minimum distance is same between C3. Is it C3? Is this C3? C3 and T2. This is why uh, you cannot actually increase or decrease the margin by simply removing one vector. They actually happens to lie in pair form. So this is why we can actually draw support vectors with the help of either these two, like this is one pair, this is another pair, or this is the pair. So we have three choices here to uh, to draw the hyperplane, and in these three choices, 4 points are actually making our support vectors. It's the same hyperplane because the points actually happens to lie on the hyperplane and have the equidistance. So margin is same irrespective of which one you remove individually. So the margin will only change when you remove them uh, together. Like if I remove T2 and T3, then margin will increase. If I just remove T2 or T3, the margin will not change. Same can be said by same can be said for C3 and C4. Okay, you can see visually.
Okay, I get it, Doctor.
Why we have here we have four and why not the previous case? Just for the reminder, in this case, if I remove it, it does not change. OK, but if I remove this one, the margin will change. So this is why it is not support vector. OK, but here
Doctor, we can't hear you. But anyway, the link for rating the session was sent in the chat. You guys should go through it, okay? Thank you.
Does that mean the session's over?
no, you just last question. I think we can end it after that. So yes. So the difference between this one and the previous one here, if I remove this point, the margin will not change. This is the minimum margin. But if I remove this one, the minimum margin is now this one. So this is why in the previous question it is not support vector, but in this question, you can see that if you remove this point, the margin minimum margin is this one, and if you remove this point, the minimum margin is this. And it's a coincidence that the distance between this distance, D1, it's same as this distance, D2. And interestingly, this is also equal to this one, which is D3. And all three distances are D1 equals to D2 equals to D3. This is why the uh, this one, and this one is actually, which is composed of these 4 points, is making our support vectors. So support vector, for what we can say about this C4 and C2, yes, both points also identify the support vectors. Okay. I should actually bring some, some like a paper pencil or something like this, or should be a little fast in explaining the. But so far, I just managed to explain these points, and yeah, I mean, otherwise, yeah, we have some more questions, but I'm not sure if we can finish it in time. So this is actually quite self-explanatory. You have the equation, the formula, and and yeah, I'm not sure we have the time to finish all others. So if you want, we can pick one more question and then we can end here. So which one do you want? This one or this one?
The
The
second.
matrix one, doctor.
You mean the Q learning one?
Yes.
Okay, so we have a reward and the Q vector. We executed 11 iterations of Q learning and the resulting Q matrix is shown below. So this is the Q matrix after 11 iterations. Alpha is 1, gamma is 0.5. And can you show it like clean version of this one? What's the formula? The clean formula. I can see it is QSA is equals to QSA plus alpha bracket gamma R and something like this. But if you can give us a clear version, it would be, I mean, much better. So just take a snippet of this one and post it in the chat. The question is, what will be the new value for QBC? So QBC, it means you are in B and you want to go to this C. So from B to C. So if you go from B to C, it means uh, it means in the C you will have these options. And let me. Yeah. Oh, okay. So what we do in Q learning is we calculate the expected reward. So from B, I'm going to C. Okay. So what I need to check is to check what is the maximum reward I will receive if I go to C. So if I go to C, this is my maximum reward, like 3, 4. So this is the maximum reward. Okay. So Q S A prime or the maximum. So here, which state we are talking about? So Q, if we are in C, the maximum reward will be received at E, and it is equals to 4. So this is the maximum reward that I will get. And so here it is 4 multiplied by the gamma, which is 0.5. 4 multiplied by 0.5 is 2. And current reward, where is R matrix? I think uh, we don't have the R matrix. It should be given on the top of it. Can you share the complete question? Because R matrix is not here. Hello?
Yeah, I think the question that was sent is lacking. So
Because R matrix is not here. We have calculated this part, but R matrix we need R value to put here. Otherwise, the rest of the calculation is just it's done. I mean, we need some R value. We have solved the question. We only need this R value for BC. RBC. Let's put it here, and you get the answer. So it's not shown here, but in the here it is saying that it's 6, if I understand it correctly. So it should be given upward. Yeah, I think this is actually connected question. You see, I'm sure the question 12 is about the R. Okay, so you cannot solve it directly. You need to calculate the R value from the question 12. Then just simply put it in this formula. So and you will get the answer. So it's
Doctor, I
just
have
like a
sent it in the chat.
yes. So okay, this is our R. Going back to the question. Yes. Okay. So RBC is -6. RBC is -6 plus gamma is 0.5, and maximum value from C is QCE, which is equals to 4. So -6 plus 0.5 multiplied by 4 is 2. So this value become -4. And you have to multiply this one with alpha. Alpha is 1. That's why answer is this one. Okay, so I think the main confusing point here is why I'm using this CE. Okay, and I noticed that many students actually find this one difficult. All other things are fine because I'm using BC value, I'm using RBC value. Okay, this is fine. Why am I'm using CE value? I'm using CE value, QCE value, because in Q learning, we use expected reward. So expected reward means if I go to C, what is maximum I can expect from C? So from C, I can expect either 3 or 4. So maximum I can expect is at this one is if I go from C to E, and the maximum is 4. The rest is just putting the values. Okay. Yes. I hope this answer or like
Yeah, thank you,
helped some.
doctor. I've sent a QR code in the chat. Can you just show it on the screen so students can scan it? Yeah, that's the QR code for this session. If you guys can scan it and rate this session. Yeah, thank you, doctor, and thank you for attending.
Yeah, welcome. Okay, should I or you can scan it yourself, or do I need to share the screen?
Yeah, that's enough.
This is for evaluation or?
Yeah.
Okay.
Okay. Yeah, this is actually first time I'm just giving it on online explanation. Usually I just present online. This is one way. So, but this is actually two-way interaction and using the pointer. And so I hope that it helped or does not make you more confused. So thank you.